Hello, very good evening, students. Welcome to BYJU'S exam prep. Good evening, all of you. Very good evening. I hope everyone is good, fine. So today in this particular session, we're gonna practice the top 10 questions from the topic, very important topic from the theory of machine, that is vibration. And you have been seeing that for the last 3-4 years, from the vibration topic, every year you're getting at least one or two questions in the GATE examination, that to 2 marks level. Okay, so I've taken all the variation of the problems. Specifically, I've taken more questions from the natural vibration because I've got some student that they're having some doubts in the natural vibration. So for more practice, I have taken question from the natural vibration so that you can have more good level of question practice. Along with that, I've taken questions from the damped vibration as well as the forced vibration. Okay, so very good evening all of you. How is your preparations going on for the GATE examination? And I know that last week you had a very good HPCL examination, and I hope so you all are having a good score. And definitely you need to again revise for the different whatever mistakes you are committed for the HPCL examination. Try to see that and try to eliminate that errors or mistakes in the ISRO exam, because next year, like 7th of December, 7th of January, you'll be having your ISRO examination. So I hope so everyone is now ready with the next examination, and after that, exactly after 1 month, you'll be having the GATE examination. So you need to buckle up and try to give your best the next 1 month, because lot many examinations going to be held. Right. Chaliye, very good evening. Please do confirm at your end my audio and video all good and all perfect, because we're gonna solve a very good level of questions. Some question will be much more than that of the GATE level. Okay, so I want your response. And why I've taken only specifically 10 questions, because I know that less questions, but whatever questions we'll be discussing, that will be very good level question, not PYQ. I'm again repeating, PYQ already you are solving at your end, at your home. Now we'll be solving some new questions which is not available in any PYQ problem. Okay. Hello, Faninder. Hello. Good evening. Good evening. All right. So shall we begin with our today's session? Yes, all good, all set. Chaliye. So let's begin our session, and I'll be sharing the PDF of this session on my Telegram channel also, right? You can do download from there also. That is Mechanical by Suraj. All the questions will be available there also. You can download directly after just completing the session. I'll be sharing that, and you can download from there. Okay, fine. This is my Telegram channel. That was we're talking about Mechanical by Suraj Gopi, and very important update on 30th and 31st of December. It's an important update for all the GATE 2025 aspirants. You can avail this scholarship test where you can get into our paid courses up to 90% off. You'll be getting on all the programs. Along with that, 27th of December, Rakesh sir will be coming up live for all the 2025 aspirants, GATE 2025 aspirants, to achieve single digit rank. What should your roadmap? Okay, fine. Chaliye, and I hope so everyone has been seeing these faces, but I want your photograph to be pasted next year. Definitely you will be excelling, but one thing you have to do is just be consistent in your preparation. Okay, there will be sometimes ups and downs. You need to overcome that. That is all about the competitive examination. Okay, fine. And ISRO examination 7th of December, 7th of January is going to conduct by ISRO. So make sure every day you are practicing some new set of questions on our app. These are free questions which are available on our application. Okay, fine. Chali. So shall we begin? I've taken a combination of questions, majority from the natural vibration, because many students do have doubt from there. Okay, so first question on the screen. A cylinder bar of mass m and length L is pivoted at a distance L by 3 from one of the end, and it is constrained to rotate in the horizontal plane with the help of the strings as shown in the figure. What will be the natural frequency of vibration? Omega n you have to calculate. Chaliye. What will be the natural frequency of vibration for this particular set of question? Now, whenever you are getting this kind of question, can you tell me which method you will be opting for? Yes, there are multiple methods. You might have studied Newton's method, your torque method, Rayleigh method, energy method, right? So can you tell me which method you will be opting to solve this question? Very easy problem. There is a slender bar, thin bar, having mass m and length L, and it is pivoted at a distance of L by 3 from one of the end. right? So you have to calculate what is the natural frequency of vibration omega n. First of all, we'll be taking the natural vibration question, then the damped vibration, then forced vibration. Okay. Yes. Quickly. Option A, option B, option C, or option D. Definitely you need to go for the torque method. Yes, you need to go for the torque method, right? And go for your restoring method, torque, which is being applied on this particular spring. Now, definitely the static weight will be nullified. The static weight of this particular bar will be nullifying the static deflection in the spring. So no need to take that mg effect. Now, whatever we left out, let us suppose I am giving some initial deflection in this direction. Okay, let's say this is theta, right? Okay, so can I say over here the deflection will be happening will be L by 3 into theta, right? This is the deflection in the spring that is having a stiffness of 2K, and the deflection in this spring will be equal to 2L by 3 into theta. Yes, just like R into theta. Now we know the stiffness, we know the deflection, that will be the spring force. Now if I try to calculate what is the restoring torque at about this point O, right? So I can say this will be 2K into 2K, this will be in this direction, 2K into L by 3 into theta into L by 3. This will be the restoring torque acting in this particular spring. And because this spring will be compressed, so definitely will be having a restoring torque in this direction, that is K by 2 into 2L by 3 into theta into 2L by 3. So if you try to write in our equation format, right? So I can say I0 theta double dot is equal to minus of all the restoring torque, that is equal to 2K into L by 3 into theta into L by 3 plus K by 2 into 2L by 3 into theta into 2L by 3. Yes? Yes? 2L by 3. Okay? Fine. So if you try to solve it, you'll be getting this will be 2K L square by 9 theta plus 4, or it would be 2 and 2 get cancelled out. That will be equal to 2K L square by 9 into theta, that is I0 into theta double dot with a negative sign. Right. Now if I try to nullify it, you will be getting I0 theta double dot plus this will be 4K L square by 9 into theta equal to 0. Now we have simplified to a very simple format, but the thing is I need to calculate what is the moment of inertia of the rod having mass m and length L about a point which is hinged at a distance of 2L by 3. Now if I want to calculate this I naught, how we can calculate? Let's say this is your CG point. This is C, right? This is L by 2, this is L by 3. Can we say this distance will be equal to L by 6? From one of the end to the center, that distance will be equal to L by 2. This is L by 2, right? So L by 2 minus L by 3 will be equal to L by 6. So we can say ML square by 12 plus M into L by 6 whole square. So this will be equal to ML square by 12 plus ML square by 36. So that will be equal to ML square by 36. That will be equal to 9. Okay, ML square by 9. Okay, so this is the moment of inertia of this rod about point O. Now placing this value over here, that is equal to ML square by 9 into theta double dot plus KL square by 9 into theta equal to 0. L will be cancelled out, 9 will be cancelled, that will be having theta double dot plus KL square by ML square. L will also be cancelled out. Okay, fine, into theta equal to 0. And comparing this with the standard equation, theta double dot plus omega n square theta equal to 0. Comparing these two, omega n will be equal to under root of K by M, right? Okay, fine. Yes, any value we are having, this is 4 will be having 4 by 4, okay, 4K. So this will be equal to 2 root K into M. This will be the natural frequency of vibration for this particular system. Are we having? Yes. Option B is the correct answer. Option B is the correct answer. Is this clear? We have applied the torque method over here. We have applied the torque method over here, and from there we are able to calculate very easily the question. And whenever you're getting a question from the bar, right, where we're having some hinge point, you always need to apply the torque method, because that is one of the most easiest way to calculate. Okay, if I say there are, if you're practicing 10 questions, at least you'll be having 6 questions which you can solve by using the torque method. That's the best method, I would say, to solve any question from the natural vibration. Is this clear? Option B, that is 2 root k m, will be the correct answer. Done? Right. So let's proceed for the next question, question number 2. Okay. A cylindrical disc having a mass of 5 kg is constrained with 2 springs as shown in the figure. R is the radius of disc and it rolls without slip. Determine the natural frequency of vibration for small oscillations about the mid position as shown in the figure. The stiffness of each spring is 3 Newton per centimeter. Okay, chalo, try this one. Acha, tell me one thing. If a body is rolling without slip, so where will be its eye center located? Anyone? That body will be undergoing pure rotation about which point? If a disc is rolling without slip on a horizontal plane or a horizontal surface, so can you tell me where will be the instantaneous center of rotation be located? Eye center for pure rolling condition. Anyone? Yes, Fanindra? Very easy question, because these type of question is checking your concept clarity. At which touches line? Exactly. We can say point of contact. We can say the point of contact. Can I say this will be the instantaneous center? That means entire body is undergoing pure rotation about this point of contact. Okay, let's do one thing. Let us try to rotate this body about this eye center. Let's say this point is O. Now, whenever a body is rotating, now we have to apply again the torque method. Let's apply the torque method over here. Okay, now let us suppose I am giving some initial deflection over here. Let's say this is the deflection I'm giving, theta, right? So in this particular spring, this distance is r by 2. Can you tell me what will be the deflection in this spring, in the lower spring? Can we say the deflection will be equal to r by 2 into theta? Because we are deflecting by a distance of r by 2 into theta, that will deflection this spring at the lower spring. Similarly, at the upper spring, we'll be having a deflection of 3r by 2 into theta. Yes. Over here, the distance, total distance is 3r by 2 into theta will be the deflection. Now, these are the spring force which is trying to restore this body. So, if I want to calculate the restoring torque, can we say the total torque, the total restoring torque? The total restoring torque. What are the restoring torque? One will be, because we are elongating the spring, one spring will, the lower spring will try to rotate this body in this direction with a torque of k into r by 2. Let me write it over here like this. The first one will be equal to k into r by 2 into theta. This is the force into r by 2. This is the torque. Now, second torque that will be rotating this body like this, that will be equal to k into 3r by 2 into theta into 3r by 2. Okay, fine. So this is the total restoring. After beyond this, there is no restoring torque. Now I can say that your I0, this is your point O, into theta double dot is equal to minus of total restoring torque, that is equal to k into, I can write it as r by 2 whole square, r by 2 whole square into theta, plus this is 3r by 2 whole square, k into 3r by 2 whole square into theta. Rearranging this equation, I'll be getting I0 theta double dot plus this is kr square by 4 plus 9r square by 4 into theta equal to 0. So this will be equal to 10 r square, 10 k r square by 4. 10 k r square by 4 into theta, or we can write 5 by 2. Simplifying this, we'll be getting 5 by 2 r square plus I0 into theta double dot. Okay, now can you tell me what will be the moment of inertia of a roller above, or we can say of a disc about the point of contact? Having a mass m and radius r, having mass m and radius r, can you tell me what is the moment of inertia about the point of contact? Anyone? About the point of contact, what's the moment of inertia? Can we say, very good TPM, I can say I0 will be equal to mr square by 2, because this is a disk, plus mr square, that is equal to 3mr square by 2. Very good. So I can place it over here, 3mr square by 2 into theta double dot plus 5k r square by 2 into theta equal to 0. Rearranging this equation, I'll be getting theta double dot plus nature. R square will be cancelling out, 2 will be cancelling out, will be having 5k divided by 3m into theta equal to 0. So omega n will be equal to under root of 5k by 3m, right? Perfect. Now, let us place the value. Mass is equal to 5 kg and k is equal to 3 Newton per centimeter. So we have to place this into meter. That will be equal to 300 Newton per meter. We can say this is equal to 300 Newton per meter, root of this. So this is root 100, that is equal to 10 radian per second. That is equal to 10 radian per second, right? Okay, so option B is the correct answer. Okay, always remember that whenever you are solving any question from the natural vibration, you have to proceed step by step. Do not skip any procedure, because if you are skipping anything in making the solution in lesser time, there is a possibility that will be skipping some crucial steps. So make sure you just go with this method and you won't be taking much time to solve in this particular fashion. Okay, fine. So option B, 10 radian per second, is the final correct answer that we are getting. Right, done. Option B is correct. Very good. TPM Faninder, is this clear? Right, will be, so I told you I'll be solving a very good level of questions. Some question will be easy, some question might you'll be getting difficulty. Okay, next question is a very easy problem. Find the natural frequency of vibration and show the figure. This is a massless pulley, right? This is a massless pulley, right? And the stiffness at the upper and the lower is basically equal, that is equal to K. Let us say this is equal to K. Okay. So tell me, in this particular question, which will be the most easiest method that will be preferring? Can you tell me which method will be preferring over here? Anyone? Which method will be preferred to solve question? Yes, quickly. 1 second, let me share it. Yes. Out of all the different methods that we have studied, can we apply the Rayleigh method? Please do let me know. Can we apply the Rayleigh method over here? Yes. Because Rayleigh method is only applicable to natural vibration. Okay, this is a question from the natural vibration. It is only applicable to the single point mass system. Yes, we do have a single point mass system, right? And there should not be a distributed mass. There is no distributed mass, right? And it is only applicable to a natural vibration system. So definitely we can apply the Rayleigh method. Let us suppose the deflection in the static deflection in the spring 2 is delta 2 and this deflection is delta 1. Can you tell me what is the value of delta 2? Individually delta 2 and delta 1 value. Because this is M, so we'll be having tension in the string will be equal to mg over here and mg over here. Right. So can we say delta 2 will be equal to mg divided by K2? Yes, mg divided by K2, and delta 1 will be equal to this is mg, this is mg, this will be equal to 2 mg. So this is equal to 2 mg by k1. Yes. Now, what is Rayleigh method? That is nothing but natural frequency of vibration is equal to g by delta. Delta is the static deflection at mass m. So can you tell me what will be the value of delta in terms of delta 1 and delta 2? What will be the value of delta is the total static deflection in the mass m. Can we say delta will be equal to this is delta 2 plus, because we are having 2 times of this one, so we'll be having 2 deflection, 2 times of delta 1. I hope you know about this deflection concept. Okay, so now we can say this is equal to mg by k2 plus delta 1 is 2 mg, so this is 2 into 2 mg by k1. K1 and k2 both are equal, so we can take it as k, right? So this is equal to 4 plus 1 5 mg by k. So this now we can easily calculate the natural frequency of vibration is equal to under root of g by delta. Under root of g by delta, right? So g by delta is 5 mg by k, root of this, so this is k by 5m, right? What's the value of k? K is 1000, m is 2 kg, so 5 into 2, that is 10, root of 100 is 10 radian per second. Okay, they're asking in, I think 10, option C is the correct answer. Option C, 10 radian per second is the correct answer. Is this clear? Done? Is this clear? Yes, everyone. Very easy. Rayleigh method. If you are getting a chance to solve a question by Rayleigh method, please do check the conditions. Conditions are, you should be having a single point mass system. Yeah, definitely. The individual delta 1, delta 2, or the delta value? I hope so. This is mg, so we can say delta 2 into k2 is equal to mg. So from there we are getting delta 2 is equal to mg by k2. This is mg, this is mg, we will be having 2 mg. So we can say 2 mg is equal to delta 1 into k1. So from here I am getting delta 1 is equal to 2 mg k1. Right? Now, when you are having, let us suppose, when you are having a connection like this. Okay. Now, let us suppose if we are having a deflection over here as x. Let us suppose if this is x, so this will also be x, right? Okay, fine. Now, if I say over here, let us suppose this entire pulley has dropped down by a value over here. This entire pulley has reached somewhere around here. Okay, right? Let's suppose this has moved a distance of x, right? Now, if this is connected over here, right, if this is connected over here, and this is the fixed end, right? So definitely we can say over here we'll be having x by 2 and x by 2, or we can say if this in this particular string it is being having a deflection of x, right? So this will be deflected by a distance of 2x. So from there we are getting 2 times more deflection. If in this particular string we are having a total deflection of x, because whatever deflection will be happening over here, same deflection will be happening over. That is the reason we have it delta is equal to delta 2 plus we have to add the superposition method. I hope so you know that is from strength of material, right? So when this is having a deflection in the string of x, this particular will be moved by a distance of 2x. Okay, fine, right? So that is being applied over here, and from there we are getting the total deflection method in this particular method. Okay, clear? 10 radian per second, option C is the final correct answer. Faninder, can we proceed to the question number 4 now? Right? In every question you might be getting some new concept. Now this type of question you might be getting because till date you haven't got a question like this in any gate examination. So let us see what is the question all about. A cylinder of diameter d and mass m floats vertically in a liquid having a mass density of 500 kg per meter cube. So density is given, that is 500 kg per meter cube. right? They are saying that it is slightly being depressed and it's depressed slightly and released. So definitely you will be getting some amount of vibration. So what is the natural frequency of vibration, they are asking you? Yes. So can you tell me, let us suppose it is actually going inside having a we can say a height of x. We are pushing by some force and it is being dipped by some, it is having some deflection of x. So can you tell me what will be the restoring force over here? What will be the restoring force that will make the body to come back to its mean position? Anyone? What will be the restoring force? Now you have to apply the concept of fluid mechanics. Can we say rho into A into X, the amount of fluid being displaced, that the same amount of force will be acting, that is basically called as a buoyant force only. The same upward force, that is a restoring force. Let's say X is the deflection happening in the we can say from this level, right? So definitely we'll be having this amount of fluid be displaced, and that is the buoyant force being applied. So I can, this is the restoring force, rho into A into X. A is the cross section area. So we can say your M into, or we can say, so we can say this is equal to your M into X double dot plus rho into A into X. This is basically equal to 0, because what is the total inertia force? That is equal to negative of the your restoring force. We know that the total inertia force will be equal to the negative of the restoring force, right? And that is equal to M into A plus rho into A into V. Okay, so rearrange this equation. This is equal to rho into A by M into X equal to 0. Comparing this with a standard equation, delta x double dot omega n square x equal to 0. So omega n will be equal to rho A by M. Root of this, just place all the values. Density is given 500. Cross section area is, this is a cylinder, so we'll be having pi by 4 d square. Pi by 4 diameter is given 0.1 whole square. Mass is given how much? Mass is given they have 1 kg. Mass is given 1 kg. Okay. So can you tell me what's the value you are getting? Solve it, tell me what is the value you are getting, and round off to 2 decimals. Okay. Round off to 2 decimals. Let's calculate 500 into pi into 0.1 square divided by 4. Are we getting 1.98 everyone? 1.981 or 1.98 radian per second is the natural frequency of vibration. 1.98 radian per second is the natural frequency of vibration of this cylinder, which is having some natural frequency of vibration if you're trying to have some initial deflection of X. Okay, fine. So 1.98 radian per second is the final correct answer. Clear hai? Understood? Very good, Shreyas. Very good. Correct. 1.98 radian per second. Perfect. Very good. Okay, let's proceed. Now let's go to the next question. Question number 5th on the screen. Okay. Now let's try to solve some damping questions where you will be introducing some damping also. A 500 kg vehicle is mounted on springs such that its static deflection is 1.5 mm. What is the damping coefficient of the viscous damper to be added in the system in parallel with the spring such that the system is critically damped? Now they are saying that initially there was no dampers. It was basically mounted on the spring, right? And it was having static deflection of 1.5 mm, right? So once you are adding, let's say initially we were only having one spring, that's it. Okay, fine. Now after that, what is happening? We are adding one damper which is parallel to the spring. We are adding one damper which is parallel to the spring, right? And such that the entire system is critically damped. So they're asking you what is the value of this critically damping coefficient. They're asking you what is the value of this critically damping coefficient. Anyone? Very easy question. Because damping questions are very, very easy. Okay, fine. So can you tell me, can we calculate the value of omega n? Because initially there was static deflection of 1.5 mm. We can say omega n is equal to under root of g by delta. So this is 9.81 divided by 1.5 into 10 to the power minus 3. So this will be giving you the natural frequency of vibration omega n, and we know that your Cc is equal to 2m omega n. Mass we know, omega n we can calculate. Tell me the final correct answer. Mass is 500 kg, omega n you can calculate. Now it's a matter of only problem solving, only the values need to place. A, B, C or D? Option A, option B, option C or option D? Let's calculate. Divide by 1.5. Okay, are we getting this to be 80.87 radian per second? है ना? B, very good Kaushik, very good Faninder. Option B is the correct answer. Now we have to place it. 2 into mass is 500 into 80.87 thousand. This will be 8.09 into 10 to the power 4 Newton second per meter. Option B is the correct answer. Option B is a final correct answer. Is this clear? And if you are getting a question like this, it will be surely 2 marks problem. And this is hardly like a 6-liner, not 6-liner, 5-liners problem. A very easy question, very easy question. But only thing you have to understand is the logic, how you need to proceed. That's it. Chalo, next question on the screen, question number 6. देखो damping आने से बहुत easy हो जाता. Question is very easy. A vibrating system consists of mass having 50 kg, the spring having stiffness of 30 kN per meter, and a damper. The damping provided is only 20% of the value. What is the ratio of the consecutive amplitude of vibration? Now they are asking you what is the value of x n divided by xn plus 1. That means x0 by x1. So basically they're asking you the value of x0 by x1, because we know that for a damped system, the consecutive ratio of the amplitudes is, the ratio is always constant. That means they're asking you the decrement ratio. Chaliye, try this. Now, in order to calculate this decrement ratio, we need to calculate the value of delta. Now, we know that delta is a function of zeta. So, first of all, we need to identify the value of zeta. Once zeta is calculated, calculate the value of delta. When delta is calculated, then you will be getting the value of this one. Now, can you tell me what is the value of zeta you are getting? Read the question carefully. And what is the value of damping factor? Anyone? Kaushik, Faninder, TPM, Negi. What will be the damping factor? Question ko dhyan se padhiye. We know one important definition of damping factor. It is the ratio of the actual damping coefficient to the critical damping coefficient. And they're saying that the damping is provided 20% of the critical value. So this is 0.2 of Cc divided by Cc. So zeta is equal to 0.2. If zeta equal to 0.2, can we calculate the delta? Delta is equal to 2 pi zeta divided by under root of 1 minus zeta square. Chaliye bataiye, what is the answer? Now it's a matter of calculation. जैसी delta आ जाएगा, we know that x0 by x1 is equal to e to the power delta. Exponential to the power, this will be your consecutive amplitude of vibration. Let us see who's going to give me the answer. Very easy question. 2 marks ही है. देखो मैंने अभी तक कोई भी 1 marks question नहीं लिया. I have only taken 2 marks problem because I know vibration में if they are getting a 2 marks question, it will be definitely not a easy one. Moderate question ही होगा and you need to solve it. 0.256. Okay. Delta का value. चलो let's calculate. कितना है? 1 minus 0.2 square. Yes. 0.256. Everyone is getting 0.256 because I'm getting the delta value to be 1.283. Yes, I'm getting this value to be 1.283. Yes, Kaushik, Negi, please confirm. Faninder, Now once you're getting this, place it over here. E to the power 1.283 exponential to the power this. चलिए बताइए कहाँ गया this 3.6058 है ना. So we can say option B is the correct answer. Very good. 3.6. So we can say the consecutive amplitude ratio is equal to e to the power delta, and that is equal to 3.6 as a correct answer. Okay, fine. देखो damping and force is the most easiest, right? Natural में थोड़ा सा time लग सकता है, some practice is required, but I would say that damping and force में you won't be getting any difficulty. Okay, done. Right? Chalo, next question, question number 7 on the screen. And now I want answers from every single student, because I've already gave you the logic to these kind of questions, right? You have to answer till 1 decimal. You have to tell me the answer till 1 decimal. Okay, let's see who's gonna give me the answer. Round off to 1 decimal. A damped spring mass system released from rest from its initial displacement of x naught. If the succeeding maximum amplitude of vibration is x naught by 2, what is the value of damping ratio? Zeta value they are asking you. What is the value of damping ratio? They have given you the consecutive amplitude. So we can say x0 by x1, that is equal to x0 by x0 by 2, that is equal to 2. And we know that x0 by x1, this ratio will be equal to e to the power delta. So from here we can say delta is equal to ln2 logarithmic of 2. And if you know the value of delta, we can calculate the value of zeta, because we know that delta is equal to 2 pi zeta divided by under root of 1 minus zeta square, right? So let us rearrange this equation. 0.012, that means 0.01. Sure, Kaushik? चलो देखते हैं. Delta square is equal to 4 pi square zeta square divided by 1 minus zeta square. Rearranging this, zeta will be equal to delta divided by under root of 4 pi square plus delta square. Are we getting the value of zeta? Something like this. Now you can place it over here. ln2, what is the value of logarithmic of 2? 0.693, है ना? 0.693, place it over here. That is equal to 0.693 divided by under root of 4 pi square plus 0.693 square. Okay. Kaushik, कितना आंसर आ रहा है? 1 decimal. Everyone, round off to 1 decimal. 693 square. Are we getting this to be 0.109? Please do check. Are we getting this to be 0.109? That means 0.11 is our final correct answer. Round out to 1 decimal. 0.1 will be the final answer. Perfect, Negi. Kaushik here, please do check. If you are getting wrong value, please do confirm. You might have taken the log value. You have to take log to the base e. Do not take log to the base 10. If you're taking that value, you'll be getting the wrong answers. Okay? Is this clear? 0.11 is the final correct answer. Very good. Faninder, are you getting this? You have to round off to 1 decimal. 0.1 is the final correct answer. Okay? So definitely this is an underdamped system. This is an underdamped system, because zeta is less than 1. And for underdamped system, we do have vibrations. Okay? 0.11. Perfect. Perfect. Chalo. Next question. Question number 8 on the screen. This is one more type of question that is being asked, like a common link problem they are asking you. Okay? The mass of the system is 300 kg. Very easy question. The stiffness K is equal to 200 kilonewton per meter. The damping factor is also given 0.25. Very easy question. They are asking you what is the natural frequency of damped vibration. Omega D value. Quickly. Tell me round off to 2 decimals. If, or we can say next integer. Round off to next integer. Chaliye, I made it slightly easy. They're asking you what is the damped vibration omega d value. Chaliye, very easy. First of all, calculate the value of omega n. What is omega n? Omega is equal to under root of k by m. Yahan pe students do commit a mistake because they are not converting this kilo. So you have to convert this. This is k by m. This is 200 into 10 to the power 3 divided by 300. Under root of this, you will be getting somewhere around 200 into 10 to the power 3 divided by 300 root of this 25.8 25 yeah 25.82 radian per second, है ना? Perfect. So we know that omega d is equal to under root of 1 minus zeta square into omega n. So 1 minus this is 0.25 square under root of this into 25.82. So if you round off, you'll be getting somewhere around 24.99. Now please do check. So we can round off to next integer, that is 25 radian per second. So we are getting 25 as the correct answer. 24.99. Are we getting this? Exactly 25. Exactly 25. Perfect. We are getting this to be exactly 25.0001. So we can say 25 radian per second is the correct answer. Very good, very good. Okay. Done. Nearest will be the correct answer. Chaliye. ठीक है? चलो next question number 9 on the screen. Second last question है. This is second last question. Machine part having a mass of 4 kg vibrates in a viscous medium. Harmonic exciting force of 50 Newton acts on a part and causes a resonant amplitude of 65 mm with a period of 0.44 second. What is the value of damping coefficient? Chaliye, this is an interesting one. A 2 marks question from the forced system, from the forced vibration. We have to calculate the damping coefficient. They have given you mass, they have given you the excitation force. They have said that the condition is resonance. They said that the condition is resonance. Okay. Chaliye. But they have not given you the value of stiffness. How we can calculate the value of omega n? Anyone who can tell me? Because we have to calculate the value of omega n, right? Omega equal to omega n, because this is a resonance condition. Anyone who can tell me how we can calculate without knowing the value of k, how you can identify? We know one very important equation, sir. Omega is equal to 2 pi by t. Here omega n is equal to, exactly, very good. From the time period, we can calculate the value of omega. Perfect. So we can say that this is 2 pi by 0.44. That is the value of omega n, right? So this is, and from there we can calculate the value of k. 85.66. Very good, very good. So what's the value of this? Divided by 0.44. This is 14.28 radian per second. Okay, fine. And we know that omega n is equal to under root of k by m. So from here we can get the value of k. K is equal to how much? This is equal to square into mass is 4 kg. 815.669 Newton per meter. Yes, are we getting k is equal to this? Please do confirm. 815.669 Newton per meter. Perfect. Very good, Kaushik. Chaliye. So we have got the value of k. Now we know one very interesting formulation, that is your amplitude of vibration. What is amplitude of vibration? That is equal to F naught. Let me write in the next page. The generalized equation of amplitude of vibration is F naught by k divided by under root of 1 minus omega by omega n whole square plus 2 zeta omega by omega n whole square. This is the general formulation to calculate the amplitude, right? But they have given you the resonance condition. Resonance means omega is equal to omega n. So this will be equal to 0. This square will be cancelled out. So we can say amplitude of vibration is equal to f naught by 2k into zeta. Okay. So from here we can calculate the value of zeta. Amplitude of vibration is 65 and that is 0.065. Force is 50, right? Divide by 2 into k value is 815.669 into zeta. So from here you can calculate the value of zeta. Once zeta is calculated, we know zeta is equal to c by 2m omega n. Zeta is equal to c by 2m omega n. Omega n value we know, mass we know, we can get the value of zeta. Chaliye, bataiye. What is the value of zeta you are getting? Quickly. Anyone who has calculated? Kaushik, Faninder, Negi? Quickly, this will be 25.06585. Somewhere around 0.2, 0.4, 0.47, perfect. 0.471. Yes, we are getting this value to be 0.471. Perfect hai. So just place it over here. Zeta is equal to c by 2m omega n. Perfect. So zeta is 0.471. C value we have to calculate 2 into mass value was, mass is 4 kg. For omega n we have calculated this to be 14.28. 14.28. So we are getting the value of C. Kitna hai? 672.88. Sure. 471 into 8 into 14.28. Yes. We are getting 53.81 Newton second per meter. 53.81 Newton second per meter is the final correct answer. Okay, clear hai? But only thing, one thing you have to understand is try to see the units. Sometimes if you are using this mm directly, that will be getting the wrong answer. So make sure you always need to convert this into our SI unit. So final answer is 53.81 Newton second per meter. Perfect. Very good. Very good. Done. Chalo. Let's move to the last question. Last question is very interesting and very easy. Okay. Interesting and easy, I'm saying again. In the figure given below, what is the natural frequency of vibration? Now here they have given you I as the moment of inertia of this rod about this point. They have connected one spring on one end and they have connected one damper on the other end. Okay. So they're asking you what is the natural frequency of vibration. They are giving you some options also. Yeah. This is I. This is I. Chaliye. What will be the natural frequency of vibration? Now, can we say what will be the deflection in the spring? That is equal to L by 4. Let's say this is the initial deflection happening. Let me write it like this. So here the deflection will be L by 4 into theta. This is the deflection. Over here, let's say the deflection is X. That is equal to 3L by 4 into theta. Yes. Now, what is the damping force? What is the damping force? Damping force is equal to C into X dot. Damping coefficient into velocity. Here we are getting the deflection. So if you want to calculate velocity, this is X dot will be equal to 3L by 4 into theta dot. Right. So we can say damping force is equal to 3 into 3L by 4 into theta dot. Right. Now we can apply the torque. This is the damping force. This is the your spring force K into delta, that is K into L by 4 theta. So we can say the net restoring torque will be equal to, the net restoring torque will be equal to K into L by 4 into theta into L by 4 plus C into 3L by 4 into theta dot into 3L by 4. Okay, fine. So now we can see that I theta double dot is equal to minus of the total restoring torque, right? Or we can say I theta double dot plus this will be equal to 3 9 by 16 L square theta dot plus K L square by 16 theta equal to 0. Now we know the formulation. Now we can, if I rewrite this equation, theta double dot plus C by I 9L square by 16 theta dot plus KL square by 16I theta equal to 0. Now this is the equation which we have got. Now if you remember the natural, we can say the equation of damped system, that is equal to theta double dot 2 zeta omega n theta dot plus omega n square theta equal to 0. In the question they are asking you only the natural frequency of vibration, that is omega n, right? So from here we can say omega n is equal to under root of KL square by 16I. KL square by 16I, that is the value of omega n we are getting by comparing. This is the equation of damped system, right? So KL square by 16I, option A is the correct answer. Okay, is this clear? Option A is the final correct. Now here some students do commit mistake, they add these two, इन दोनों को add कर देते हैं. Okay, sir, can you please explain the I'm not able to see your comment. One second, let me check in my chat box. Can you explain the concept that we don't consider the point mass in system if given? Over here, because they have not given. In this particular question, they have stated that this entire rod is having a moment of inertia of I. It is not a point mass. It is a distributed mass, right? Whenever they'll be talking about point mass, they'll be having some diagram like this. Let me show you that diagram. Something like this. M will be connected. Like in this question, if I say in this particular question, in this question, if you try to visualize, they are directly given you a mass M. This is a point mass, right? Let us suppose if they are not giving you, let's say they are giving you a rod having a mass M and length L, then you cannot consider this to be a point mass system. There you have to take the torque, you have to just take a distributed load. Okay, fine. सर कुछ क्वेश्चन में लोकलाइज मास दिया रहता है, वो अपन टॉर्क में इंक्लूड नहीं करते. हाँ, क्योंकि देखो एक्चुअली क्या होता है, अगर मान लीजिए लेट अस सपोज हमारे पास कुछ इस तरीके का क्वेश्चन है. लेट अस सपोज एक रॉड है, कौशिक देखिए, देयर इज अ रॉड, है ना, और यहाँ पे मैंने एक मास रखा हुआ है. लेट अस सपोज इसका मास m है, इसका मास स्मॉल m है, और यहाँ पे मैंने एक रखा हुआ है एक स्प्रिंग. लेट अस सपोज, और इसका बोलते हैं कि इसको निकालना ओमेगा n, राइट? अब हमेशा कभी भी आप देखते हैं mg इफेक्ट कभी नहीं लेते. व्हाई mg इफेक्ट इज नॉट बीइंग टेकन? बिकॉज mg विल बी कैंसलिंग आउट बाय स्टैटिक डिफ्लेक्शन, है ना. जो mg वाला होगा इफेक्ट, मान लीजिए इसका ही मास मैं ले लेता हूं, दिस mg, द मास ऑफ दिस रॉड विल बी नलिफाइंग द स्टैटिक डिफ्लेक्शन. और जब इनिशियल डिफ्लेक्शन लेते हैं, देयर वी आर नॉट टेकिंग द स्टैटिक डिफ्लेक्शन. व्हाई? क्योंकि स्टैटिक डिफ्लेक्शन वाला कंपोनेंट इज बीइंग कैंसल्ड आउट बाय द mg इफेक्ट. दैट्स इट. That is the reason we never ever take the mass effect in the horizontal system. तभी तो हम लोग टॉर्क मेथड सबसे बेस्ट मेथड बोलते हैं, because in the torque method that mg effect will be nullified. Okay, that mg effect will be nullified. हाँ, अगर क्वेश्चन ऐसा होता, let us suppose question was like this, right? इसमें mg, इसमें भी देखो, अगर आप देखेंगे, अगर मान लीजिए रॉड होता, यहाँ पे एक रॉड होता, राइट, ये रॉड, ठीक है, मान लीजिए रॉड है और इसके नीचे स्प्रिंग लगा हुआ है, ठीक है. तो इसमें हम कैसे करते हैं? वी कैन अप्लाई दिस टू बी ए सिंपल मेथड लाइक दिस, के ऑफ द रॉड, ये m, ये आपका एक सिंपल पैरेलल सिस्टम हो जाता. वी कैन कैलकुलेट द वैल्यू ऑफ के इक्विवेलेंट. ओके, फाइन. तो हमेशा याद रखिएगा, whenever we are having a horizontal system, don't worry, the mass will be cancelling the your static deflection. और इसी कारण torque method is one of the finest method to solve the question from the natural vibration. Clear? Fine. Okay. So that is it from my side. The top 10 questions I have taken almost all the 2 marks problem. उसमें कोई easy वाला question नहीं था कि direct by seeing the option you will be getting the correct answer, right? So along with that, from 30th of December, the next mock test will be unlocked. So make sure everyone is registering before that. 30th को इसी साल कर दीजिए. Do not wait for the next year. On 30 or 31st of December, try to attempt that second mock test that will be scheduled from this date. क्योंकि mock test जितना ज़्यादा solve करोगे, you will be getting more understanding, more confidence will be built up. Okay, so that's it from my side. And in the app classes, I have planned some practice session, this kind of practice session on our application from I think second week of January. So we'll be having the mock test. Precisely, we'll be having mock test, and the timing will be 12 p.m. ठीक है, तो उसमें भी आप मुझसे जुड़ सकते हैं. I'll be sharing the complete schedule also. Don't worry. Right. So that's it from my side. For 2025 and 26 course has been launched. Those was planning for 25-26 is a complete dedicated course for GATE and ESE is being launched, right? And you can download the PDF on my Telegram channel, that is Mechanical by Surya. That's it from my side. Thank you guys. Bye bye. Take care. Stay safe, and do connect on me. Do connect with me on my Telegram channel, that is Mechanical by Suresh. Okay. Thank you. Bye bye. Take care. Stay safe.